Okay, everyone. Welcome to PyCon 2020 Coronavirus Edition. My name is Harry. You can find me on Twitter at HJWP. I am representing a website called cosmicpython.com. Cosmic Python, I'm sure you're wondering. What is that all about? Well, in ancient Greek, cosmos was the opposite of chaos. So what we're talking about on that website is how to make sure that your Python code stays the opposite of chaotic as much as possible. So that's what I'm going to be talking about. One possible technique for this is to stop using mocks. Stop using mocks? What? Okay, I should say I am being a little bit controversial here in the title. I wouldn't call it exactly clickbait, but let's say stop using mocks for a while. So that's what I'm going to pitch for you today. Where did this all come from? Well, I'm known for talking about test-driven development, but in the last couple of years I've been taking an interest in software architecture. So I've been working at a company called made.com where, we're following kind of the hero's journey here. I think all presentations to tell a story. So the hero's journey, we have the call to adventure, meeting with the mentor, refusal of the call, and we go off and fight monsters. In this case, it's not going to be monsters. It's going to be design decisions for code. But nonetheless, there's going to be ins and outs, pros and cons. And then we're going to return with the elixir. That's the end of the hero's journey. You can look at that hero's journey if it's not familiar. Anyway, return with the elixir is I'm coming back to my village, to my Python community, with some treasure, with some elixir, with some ideas about how to structure your code. And one thing I think you can do is that if you stop using mocks, you can learn some interesting new ways of dealing with certain things in your code. So that's what I want to get into today. Thank you for coming. And if you're watching this during the lockdown, like I'm recording it in whatever state it is in your country, I hope you're seeing kind of the upsides of this strange situation we're all in, and minimizing the downsides as much as possible. If you're watching this on the other side of the COVID-19 crisis, well, then I just hope that all of the fashion choices that have been prefigured in the Mad Max movies have truly come to pass, and that you're really rocking out some great sort of post-apocalyptic punk clothing. Yeah, so please put your hand up if you use mocks in your code. Fine, I'm going to assume that's everyone. So why would I want to stop using mocks? What's that all about? Well, what it's all about is learning a new technique, and I'm not saying that mocks are bad and you should never use them. Once you take an interest in kind of software architecture and software design, the cliche is that it's all trade-offs. It depends. And so what I'm trying to say is, like, mocks is a common tool that we reach for. Let's try out using a different one, and you might find that in some circumstances you've got a better tool, and in other circumstances you don't. So I'm going to talk a lot about pros and cons in this. There's no black and white. It's really just pros and cons. So every time I introduce a new idea or a new pattern, I'm going to talk about the pros and cons of it. All right, without any further ado, let's get into it. So if you're anything like me, you've learned programming by doing it. I've learned most of my programming by pairing with other developers who are smarter than me. Most of what I've learned about software architecture has been from my colleagues at made.com, and particularly in the sort of meeting with a mentor bit, a guy called Bob. Bob and I ended up writing a book about this, which is called Architecture Patterns with Python. You can find out more about it at cosmicpython.com. And Bob and I were like working in a certain business domain, and so I guess I learned some of the things I'm talking about from programming with him. And so I want to try and recreate that a bit for you by having like some example code that we can use to illustrate the ideas we've got here. So the example is in the world of logistics. And let's imagine that you've got shipments of stuff that you want to track. So a shipment is going to be a collection of products. So a shipment is going to have multiple order lines. An order line is like a certain quantity of a certain product. I identify the product using a product ID called a SKU, stock keeping unit. You might have come across that. And there's a quantity. And then the shipment has a series of lines, which is a list of those orders. And then it has its own reference number, it has an ETA, it has an Incoterm. You don't need to understand the exact details of this. What I'm trying to do is show you something simple, and then I've thrown a few bits of business jargon in there just to kind of hint at the complexity of real life. Because the problem with presentations like this is that you have to have a simple example, And most of the time, the patterns or the ideas you're trying to instill are like most useful in complex cases. So to hint at complexity, I've got a bit of random jargon. Incoterm is something to do, and I'm not even sure about this, it's something to do about like the legal state where the cargo changes ownership. Is it like when it leaves port? Is it when it arrives at the other port? Whatever. Incoterm, yeah, it's an attribute of a shipment. So here are our like models that we might have representing the data in our system, and maybe we have a way of saving them to the database. And here's our first business requirement. When I create a shipment, I need to sync it to the cargo API, to a third-party API. So part of this talk came from a conversation with Brian Ocken. Hi, Brian, of the Test and Code podcast. And he said, Harry, people are always asking me, how do I write tests against a third-party API? So that's what I'm going to talk about today. I've talked about it a bit on his podcast. I've talked about it a bit on a blog post on cosmicpython.com. I'm not sure if I mentioned that website. But even better, here I am talking about it at PyCon. So when we need to create a shipment, we need to sync it to a third-party cargo API. What does that look like? So in my code, I've got a function here. This is kind of like a controller function or a kind of a business service in my code. So if you're using Django or Flask, this might be something in like a view or something you call from a view. Anyway, to create a shipment, I'm going to take some quantities of products. Basically, I'm imagining that's a dictionary of product IDs and how much of each one I want, and an Incoterm. I'm going to generate a random reference for it using UUID. Going to build up my model objects, some order lines and a shipment. I'm going to save it to the database there at line 15. And then the next thing I need to do is sync it to the API. And so I've hidden that in another function for you. What does that look like? Syncing it to the API. Well, I'm going to take my shipment. I'm going to build like some attributes out of it into simple data structures, and I'm going to basically send them as JSON to a third-party API. There it is, request.post, and I have some data. And the kind of stuff that's going on here is the kind of stuff that I hope is familiar to people watching this. We munch some data around, we turn it into JSON to match some sort of third party's requirements, and we fire it off. So far, so good. How do I test it? Well, the classic thing is we reach for mock, specifically the unit test.mock module, and two specific techniques are patching and the use of mock objects. So at mock.patch is going to say, okay, well, when I run this test, instead of calling out to the real external internet, I'm going to call out to a mock object. So for the duration of this test, mock.patch will stop requests from calling out. And so when I call my create shipment function, I can set some assertions about what the expected data should be, and then I can say that I should be calling request.post with certain call arguments. So that's what my tests look like if I use patch and a mock. So far, so good. All right, so I had my requirement. I need to write a test for it. I've got one test, and I would say that that is not the most beautiful and readable test I've ever seen, but it is certainly manageable. If you've used mocks a few times, you can look at that and you know what's going on. But life never stays that simple, does it? Here's the second business requirement. Do a post for new shipments and a put for existing ones. Well, typically an API, for whatever reason, it's RESTful, and like they may already have a shipment of that particular reference. If you do a post, that's an error. You need to do a put because you're saying you're modifying an existing shipment somehow, whatever it is. So my sync to API code is suddenly a lot more complicated, right? I'm going to have to find my same request.post that I did before, but in the other possibility, I need to do a put. And how do I tell? Here's the fun part, right? To check whether something exists or not, I need to check that it's in their database, so I need to do a GET request first, and then of course I'm going to say that maybe they use a slightly different reference number from our reference numbers, and I need to look that up. And again, you don't need to understand the specifics of this code. I'm just showing you the kind of code that you should find familiar. Something that seemed initially simple is a little bit more crufty. More importantly, but this is a straightforward requirement you might encounter every day. More importantly, what effect does that have on our tests? So let's imagine making that test for the put. This is how I ended up writing a test for this example. I need to now patch out not just the request module, but also the UUID module, because I need to check that we're, why is that? Because I need to make sure that the GET request has an object that already has the UUID that the create shipment function would have generated. And so I'm going to have there an assertion about, I'm going to have an assertion there about request.post called is false, request.put should be called. The test is a lot longer. I'm hopefully feeling a little bit less happy with this. 2 tests, and I'm definitely getting up to a sort of medium horribleness level. I've got 2 mocks. Reasoning your way through that kind of test is a little bit more tedious. And so I hope this is the kind of situation that you're all familiar with. Let's just go ahead and take it to the next level though. Third requirement, fine, you've sent shipments off to the third party. They now know how to take your stuff onto a ship. The most important thing is we need to know the ETAs of those products, because then we need to know when we're going to be able to sell them to actual customers. So, when's it going to get here, basically? We're going to poll the third-party API to find out when things are arriving. Eesh, there's a lot more code here. Again, you don't have to understand it, but this is the kind of code you might write to go and pull this imaginary shipment, pull this imaginary shipments API, and just think about the number of tests you might need for this sort of thing. I've tried to write the code that looks a bit more like the typical business code we work with every day. So I'm going to have something like saying, if I tried to look up a shipment, it wasn't there, then that's some sort of error. So I need to have a test for that where we set it up. Oh, shipment is missing. Here's the warning. Here's what we do. Test number 2 is I need to poll a new API endpoint. So I'm going to need to mock out this new API endpoint. And there's a business case where we say, okay, well, the ETA has not changed, in which case early return. Fine. I need a test for that. And then flip side, supposing it's not, it is different and the ETA is greater than our current ETA, that means there's some sort of delay. So I'm going to imagine the business want us to make some sort of notification, right? Like notify this shipment is delayed. So that's going to be a test, and maybe a test that it does happen and a test it doesn't happen. That's 2 more tests. And then again, I'm imagining some other business case where particular Incoterm with the lines being longer than a certain length means it's a large shipment, so that needs to go through another process. So we have another 2 tests and we save it. By my count, that is somewhere around 12 or more tests. Each one of those tests is going to have to mock out 3 different things. The get for journeys, the get for existing shipments, the post and the put. And we're entering into the kind of the mock horror that you get, where each test has got 5 or 6 different mocks in it, and it's really hard to reason about what's going on, and the elder gods are stirring. And that's not even to say, here's another requirement. People say mocky tests are brittle. Every single one of your patches says, I'm going to mock out requests.get in your module. But if you, instead of doing import request, you do from requests import get, all your tests are broken. Or if you decide you need to use request.session because you need to transfer, some performance reason, you're going to reuse the same session or do some cookies or something. Basically, small changes to the implementation of your code that make no real difference to the way you're making your requests are going to break all of your mocks. So when you use mocking and patching like this, you have tests that are brittle as well. So let's recap pros and cons. I'm going to talk about this every way. We reach for pros and cons. We reach for mocks because they're familiar, because it means that we don't need to make any change to the code we've written, right? I can just write my sync to API function with its requests all the way. And the magic of monkey patching, I can just jump in there and write a unit test that doesn't talk to the real internet. So they're familiar. And I say low effort. I mean, it's actually quite hard to write these tests, but it's low effort in the sense that I don't have to think too hard about changing things. I can just use mocks like I always do everywhere else. And the downsides I hope I've illustrated, but basically mocks mean that your tests are tightly coupled to implementation details, to the specific way that you import the things that you're mocking out, for example. But also your tests are testing implementation details rather than testing behavior. A second slightly more subtle point perhaps is that you need to remember to call mock.patch with every single test. So I don't know if you've ever seen you run your unit test suite and it suddenly hangs and you realize, I forgot that one of these tests is calling that thing and that thing calls the internet and the internet is slow and that's why my tests have hung. And so you need to remember to put those mock.patches on all the tests that might possibly talk to the third-party API. And finally, it makes it too easy to mix up business logic and I/O concerns. So all of that stuff in my tests about like JSON and which get endpoint and what the IDs are has got nothing to do with the business logic that I was trying to represent in my example here. And the business logic is, if the shipment is late, then notify the following people. If it's a large shipment and it's on time, then I need to do these things. I'd like to separate in my code the idea of like what is JSON and what goes in a dictionary with the idea of like what are my business rules, and mocks don't force me to do that. And on top of all that, I can write all of these mocks, but I'm still going to need some kind of integration test or end-to-end test to reassure myself that things actually work. You may have heard the joke of like mocks testing mocks, and not, like you've got so far removed from the real world that you need some kind of reassurance that things really work. In other words, you can find yourself sliding down to what my friend and tech reviewer Ed Young calls mock hell. Ed, by the way, gave a talk at last year's PyCon, so if you've seen his talk, which is called, I think, Mocking and Patching Pitfalls, that he's also given under the title Mock Hell, I like to think of this as a kind of a recap and a sequel to that. So like once you're in mock hell, let's talk about the alternatives. So let's stop using mocks. All right. So what should we do about it? Here are my suggestions. Suggestion number 1, build an adapter. What do I mean by an adapter? I mean, let's build a wrapper around the third-party API that I'm calling out to. Let's build a wrapper around the I/O that I need, and let's give it an API and let's separate it from the core of our application, the core of our business logic. So a thin wrapper. Why have I used the word adapter instead of just saying wrapper? It's a bit of a shout out to ports and adapters, which is an architectural pattern, which we talk about more in the book. You can find the book on cosmicpython.com. I'm not sure if I mentioned that. Ports and adapters is an architectural pattern. If you've done any reading about this, you might have come across hexagonal architecture or ports and adapters or onion architecture or clean architecture, and these are all very, very similar architectures. And one of the things they try to do is help you to separate your kind of low-level infrastructure concerns from your high-level business logic. So that's why I'm calling it an adapter. But let's look at the example to see really what it looks like. What I'm going to say is I'm going to use a class here to represent my adapter. You don't have to use a class. I like to avoid using classes wherever possible. If you've never seen a classic PyCon talk called Stop Using Classes by Jack Diederich, I very much recommend it. But for the sake of this example, it's nice to think of like the API as a thing. I'm going to make it a class and it's going to have an API. And what I mean by the API having an API is it's going to have a couple of public methods. So what I'm trying to do when I build this wrapper is say, okay, well, what does my business logic, what does my application need from this third-party dependency? In my own language, not in the language of the third party, but in my language, I need to sync things to it. And I need to get the latest ETA. You might call this something else. You might call it send, or you might call it initialize. And then the get latest ETA could be called like retrieve shipping update or whatever you like. But I'm going to phrase it in my language, which makes sense and makes it look nice in my code. And then I'm going to hide the kind of language and the complexities of the low-level details of that API behind my wrapper, behind my adapter. So all that stuff about get shipment ID and doing a get to find out if it's going to be a post or a put, I can just ignore that in my application code. And actually, I should say that we kind of reach for these suggestions, for these solutions intuitively. Even when I wanted to show this example code, in the very first slide, create shipment, I did like the create shipment stuff where we do the models, and the stuff, I put sync to API into a separate function automatically. But I'm just saying, make this an explicit step in your structure when you're saying, oh, I've got to integrate with some third party on the internet. I'm saying, make an adapter, make a thing, give it a name. What effect does that have on our tests? Well, instead of patching out the requests module, I'm going to patch out my own real cargo API class. I'm going to, and then when I call create shipment, I can say that the mock cargo API was called in the following way. So it's sync.calllogs were a call of shipment. And this is, well, I would say if you cast your mind back to the very first test, my assert used to be like assert mock request dot post dot JSON double equals. I've simplified at least a little bit what my tests look like, because instead of mocking out the request module and all its complexities, I'm mocking out an API that I control that's a little bit cleaner. So that was step 1, and let's already take a step to consider the pros and cons. On the pros side, people who are into TDD and testing techniques and mocking and patching techniques have this rule of thumb saying, don't mock what you don't own. And I've got to be honest, I don't understand all the full complexities of that, but part of what's going on here is to do with this rule, which is that when I mock out the requests library, the request library can do hundreds of things, right? It can do post, put options, it can do sessions, it can do, creating adapters that, change the way you do your HTTP requests. But when I mock out my cargo API class, it's much simpler. I don't need to worry that my code, I know that it only has two possible functions, sync and get latest ETA, so I don't need to worry whether or not I'm calling post or put or patch or options or whatever else. And it means that the mocks are easier to write and that I have more confidence about what my code is actually doing because my mocks are simpler. I think perhaps more conceptually, I have decoupled already my infrastructure code from my business logic. So I've said, what do I want from my cargo API? I need to be able to sync and I need to be able to get latest ETAs. And if later the business says, you know what, forget that third party, we're going to talk to a different third party, we want to send our shipments to them, and they use a completely different integration system with XML instead of JSON because they love the 90s. I can go ahead and make all the changes to the way that I integrate and make a new version of that wrapper, that adapter, but probably it still has the exact same sync method and the exact same get latest ETA method, and so all of the tests for my core business logic don't need to change. So I've bought myself a bit of future proofing. I've allowed my infrastructure concerns and my business logic to vary independently. I've done some decoupling. Those are the pros. The cons are nothing comes for free. There's more code. I've had to build this class, which I otherwise wouldn't. I've had to put in an extra layer, and that is always extra complexity. People will look at this and go, what the hell is real cargo API? What is .sync? Where before, you could just look at request.post, and everybody knows requests, and they know exactly what request.post does. That's step one, but we're not going to stop there now. Come on, the title of this talk is Stop Using Mocks. So let's get on to the second suggestion, which is build a fake of your adapter, aka stop using mocks, part one. Instead of using mocks, I'm going to encourage you to build a fake. What is a fake? What is the difference between a fake and a mock? I don't want to dwell into this too much. But basically, whilst a mock is an object that is going to pretend to do things and that I can later ask questions of my mock saying, hey mock, who called you and what did they call you with? That whole assert mock.calllogs.blah. A fake is a different kind of test double. It's a different kind of fake thing that you're swapping out a real dependency for a fake dependency. But instead of asking it questions later, it's going to build a simplified but functional version of the real thing that you're replacing. Let's see it in real life, and I think this will all make a bit more sense. So if you feel like it, you could define an abstract base class, or if you're really into type hints and PEP 544, you could define a protocol, which says that a cargo API needs these two methods, get latest ETA and sync. And so the real one that talks to the real internet has a get latest ETA and a sync. And then I'm going to build a fake version of the same thing that has these two public methods, get latest ETA and sync. But it's going to behave like a real cargo API, but it's actually going to be a fake one. It's just going to store stuff in memory. And so a lot of times you'll end up doing this. It's just a little in-memory thing where if I sync something to it, it takes the shipment object, it's going to pop it into a little dictionary keyed on reference. If I ask for the latest ETA, it's going to go and look in that dictionary for that reference and give you back the ETA for that shipment. And then I've added a little dunder contains method. So it's a wrapper around some kind of container. And so that dunder contains method is going to be a lovely bit of syntactic sugar that I can use in the next bit. Let's see the effect it has on the tests. I'm still using mock.patch, but I'm going to instantiate my fake API object. I'm going to say using the mock API.return value, I'm going to say in these tests use this fake instead of a mock. When I call create shipment, it's going to use that fake API, and then my assert is just assert shipment in fake API. when I create a shipment, the shipment should end up in the fake API. So I hope you'll agree that that ends up a much more readable test than what we had before. And if you cast your mind all the way back to the sort of whole mock request.post.call args equals expected args, blah, 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 you can see how we've started to make our tests much more readable by building a fake API. So yes, I can get more readable tests. But what about the cons? And we'll come back to exerts design pressure. What about the cons? Well, I've got even more code in my test. So I had building an adapter, I had more code in my application code. Building a fake, I've got more code in my test code. So I've had to build this whole class fake API thing, and I've given myself a maintenance burden. Every time I change the real API, I need to go back and manually change my fake API in a way that I wouldn't have to do with a mock. So I've given myself extra work, and it buys me one thing, which is more readable test. Does it buy me anything else? Maybe this is arguable, but this idea that it exerts design pressure is an interesting one. What this is saying is that when I'm trying to make my adapter, my API adapter, my sort of real cargo API, and I'm trying to make it look nice, what is exerting design pressure on that? Well, when I use it in my code, when I'm writing my create shipment method and I go, okay, now so I'll do api.sync. What is making that API nice is the fact that I use it there. By using it in a second place and by forcing myself to have to re-implement that API as a fake, I am going to get much more signals about whether I've made a nice, simple, usable wrapper, something that's understandable. The harder it is to build a fake of your thing, the more you're going to ask yourself whether your thing is too complicated. And if it becomes really hard to build a fake, you might be thinking, hang on, like it's so hard to fake this out. Maybe this should actually be two objects, like two simple objects combined. And that's what I mean by exerting design pressure. Like the hard work you give yourself writing that fake is maybe going to translate into more signals about how to keep your code clean and manageable. That's the theory. And really, like this is the kind of thing which you're only going to find out by trying it out. So that's what I'm trying to do in this whole talk, is give you some ideas, try them out. So without further ado, let me give you another thing to try out. And if you thought that last thing sounded like a little bit of a lot of work with questionable benefits, the next thing is practically a swear word or a taboo in the Python world, which is you should use dependency injection. So this is my stop using mocks part 2. I've said instead of using mock objects, you should use fakes. And part 2 is instead of using monkey patching, unit test.mock.patch, I should think you should try using dependency injection. Now, if that is already putting your hackles up and you're starting to think this sounds like enterprisey Java-y stuff, again, I'm not trying to change your entire life. I'm just trying to get you to try something out. And so instead of trying it out in real life with code, why not even just try looking at what the code looks like in my example? So dependency injection just involves adding an extra argument to my create shipment. It says, basically, in order to create a shipment, I need to know what quantities, what products, and what quantity. I need to know an Incoterm because blah blah business, and I also need a cargo API because to create a shipment I need to sync it to a cargo API. I'm going to make that explicit in the function that creates shipments. And the rest of the code doesn't change. Basically, instead of instantiating a cargo, importing the cargo API and instantiating it in this module, I'm going to get it passed in. So I'm going to get it passed in. The injection, or the dependency is passed in. Let's see what effect that has on my tests. So I instantiate my fake API, and you'll notice there's no more mock.patch stuff at the top of the test. When I call create shipment, I just pass in that fake API, and then I say assert shipment in fake API. So I create a fake API. When I call create shipment with that fake API, I say the shipment should be in the fake API. And I think that is the simplest and most understandable test for this particular bit of code. And again, if you compare it back to the old version with its mock.patches and its, dot return value kind of stuff, this is much simpler. And if you think all the way to the whole mock.post.request.called and the whole accidental thing where we had to monkey patch the UUID module, you can see that potentially at least this buys you some really nice readable tests. So that's one of the pros, nicer tests. Second possible pro, and this is maybe a bit more subtle, but you remember when we had to remember to patch out every single test that might possibly talk to a third-party API? Well, by making the dependency required, by making it a required argument, I can't possibly write a test for create shipment unless I pass in some kind of cargo API. So I don't need to remember. I know that when I call it, it's going to ask me for one. And then there's this arguable benefit. The dependency is now more explicit. This is, people were trying to tell me this when I first came across the idea of using dependency injection, and I still think this is totally debatable. But when I look at the create shipment function, I can immediately see it requires a cargo API. So when I'm trying to find out which bits of my code have dependencies on the internet or whatever third-party dependencies, maybe you're syncing some cloud file storage or sending tweets, or I don't know what it is. You can see that right in the signature of the function you're calling. It needs one of these. And you don't have to go and hunt at the implementation and look at it and see, does it import requests, and stand through the code and say, oh yeah, it's calling request.post. Your dependencies are explicit. So, the best way of finding out whether or not that is a good thing is by trying it out. But of course, none of this comes for free. So my production code has grown this arguably unnecessary argument. And then dependency injection, like passing these dependencies around, gets more onerous, it gets harder work the more layers there are. So I have just one at the moment. Create shipment uses the API, but if create shipment called a thing saying reassess shipment, which called another thing saying frobnicate the shipment, which in turn called the API.sync, then I would have to pass that argument down through a chain of functions, and that would be tedious. There are ways of handling that. You can use dependency injection libraries, which help, but I'm not going to sit here and argue for those because I don't always love them. You could also use architectural patterns to try and minimize the difficulty of this, and we talk about this a bit more at cosmicpython.com or in the book which I've written. I don't know if I mentioned I've written a book about this stuff. Please find out more about it. It's entirely free. You can read everything I've written entirely for free online. But yeah, this could get more onerous with more layers. So this is something you have to try out and see whether the pros outweigh the cons. But I just wanted to say this thing about an unnecessary argument is the real one that I got stuck on in my life. I just couldn't do it. I think when people were saying to me, "Well, try a dependency injection, you don't even buy us all these things," and I can't do it. I can't. Adding that unnecessary argument to my create shipment function, I can't do it. I know I just import stuff. That is the cleanest way for the code to be, is I import it at the top and then the code just has it there. And you've asked me to add an extra weird and unnecessary argument to this function, and I refuse to make my application code ugly just for the sake of making my test nicer. Maybe it's Stockholm Syndrome, but I've managed to get over that. And I think you should at least try it to see what it's like too. But the argument really is, it's like, what are the things that would justify changing your application code? Making it more readable, making it more maintainable, trying to make it more better organized. These are all good reasons for changing my application code. And then I had this thing where I was stuck and saying, like, making my tests easier to write was not an acceptable reason. But in the end, the tests are part of your application, and if you can make your tests, twice as easy and more maintainable at a cost of making your application code 10% harder to maintain and read, that is possibly a good trade-off. So at least think about it. All right, so wrapping up, I have a couple more things to talk about. So you may say to me, okay, haha, well done, Harry. We've stopped using mocks, but we still have that original problem of mocks, which is that you're still going to need some kind of real test to check whether it really works. So, well done, you can write a test that a fake works, but you're still going to need to check whether the real thing works. And how do I test the actual adapter? I've taken a punt on testing that my adapter works, maybe I end up using mocks to test that. And so I'm going to suggest that this is a piece of code, your adapter is a piece of code whose whole job is integrating with a third party. And I'm going to suggest the best kind of tests for that are integration tests. So let's look at that. What would it look like if I did use mocking and patching to test the API? Instantiate API equals real cargo API at the top. I'm going to try and call API.sync there at line 9. I'm going to wrap that up in a mock.patch call. And I have the same kind of ugliness that I had back in the original setup. And I'm going to say, if you can avoid it, don't do that. Use an integration test. load up your real cargo API and point it at some sort of sandbox. So hopefully the third party you're talking to has a sandbox or a test account you can use, and then actually sync a real shipment to it, or an actual shipment object. And then when you want to assert has it worked, I'm going to go and actually poll that API using requests and say, did the shipment arrive successfully? Did the right data get through? I think this is the best kind of data that's going to tell you that things really have worked. And notice also that here's the test for the post request, which is my happy path earlier. And the second test we had in the story where we said, oh, hang on, you need to do a put request if the shipment already exists. And we got into that whole thing about, oh, like monkey patch out the UUID module and make sure it looks like there's already one and blah, blah, blah. That test can become much more readable. Where you say, if you can update a shipment, the second request should be a put request. I'll just do 2 requests. Right? I'm going to sync something, I'm going to make a change to it, and I'm going to sync it again, and I'm going to assert that that got through. And the fact that under the hood that's used a put instead of a post doesn't matter. The important requirement, and you get into this idea of testing behavior rather than testing implementation details. The important thing is, if there is already a shipment, I've synced it once already, or someone has synced it once already, when I do it the second time, it still works. The important thing is it still works the second time, not that you did a put versus a post. So that test is nicer and more readable and closer to what you want. So yeah, you might agree with me, and fine, great, of course integration tests might be the best kind of test for your adapter. But you do need a test sandbox. What if I don't have one? That's a good question. But even if you do have one, test sandboxes, right, like your third parties might not invest quite as much money in their test sandbox as they might be in their making in their real production system, and they are often they could be slow and flaky, and they could lead to slow and flaky tests, which, as we all know, are no fun. And don't forget also about cleanup, right? So if you've got 3 or 4 different developers all working on this thing all day, you're going to need to make sure you don't step on each other's toes. I mean, you're going to generate unique IDs for everything. So 3 or 4 developers running the test 5 or 10 times an hour, and then there's an continuous integration loop running a test every time someone does a git push. And I certainly remember one third party that we were doing this with that called us about 2 weeks into our integration and saying, guys, there are 100,000 new objects in the sandbox account. What have you been up to? Because we'd never figured out a way of deleting them afterwards, and the sandbox was getting slower and slower. So you do need these things. And that kind of leads me on to my third or my last suggestion for you, which is, okay, you could build a fake API for use in your integration tests. So I'm going to say, if you have real problems integrating with the real thing, why not build a fake thing? There is definitely a faint smell of danger here. So just bear with me for a minute, and let's just see how easy it would be to build a fake version of a third party that you're integrating with. Rather than depending on the actual third party, what if I just spin up a little Docker container along with the rest of my containers, or however it is you're spinning up your test environments, and it's just going to pretend to be that third party API. It's going to behave just like it does. And it's actually remarkably simple. I've written a few of these in my time. They fit on one page of code typically, because most of the things that you integrate with are some kind of CRUD, create, read, update, delete wrapper around some sort of database. And a REST API typically says, if you post stuff to me and then you do a get, you'll get things back in more or less the same shape. And I can fake that out by basically saying, if you post that to me, something to me, I'm going to store that in an in-memory dictionary. And if you ask me for a get, I'm going to fish out the exact JSON that you posted to me and send it back to you. Modulo some small transformations. So building a fake version of your third party is remarkably easy. And what that will buy you is you will get more reliable tests, right? Because instead of talking across the real internet, you're talking across to a fake that you control. And if that third-party API is not a major part of your application, right? Like I'm sure for the 3 weeks that you're integrating with the shipments API, you're like really caring and swearing about it. But 6 months later, it's a thing that you solved ages ago. It never goes wrong in real life, but your tests are always failing because their sandbox is flaky or because whatever. And it's not that business critical to your application. You're wondering how come you're breaking your build twice a week for a thing that never breaks in real life, maybe swapping it out for something more reliable is a good thing. And remember, okay, so is there any point of these tests left? Yeah, you're still testing that your adapter can make actual calls across HTTP, right? Because you're going to make that call to a separate container. You're going to test that you're encoding JSON correctly and decoding it and whatnot. And of course, you can still give yourself the option of running the tests against the real sandbox now and again. And so this is something to think about. Like maybe we've had things where we run the tests against the real sandbox in CI, but not on your local dev machine. Or once a day in CI at 6 a.m. it runs against the real thing, and then all the regular tests during the day run against the fake thing. Or maybe even smarter, like it looks at the code that's changed, or it looks at the title of the pull request to decide whether this looks like code that has changed an integration and it should run against the real thing, or it should run against the fake. But you might find that this buys you a lot and lets you have proper end-to-end tests that are not slowed down by an external dependency. So that's just the last area that I wanted to leave with you. There are other topics that you could get into once you start having a fake that passes against, like you have a series of tests that pass against a real dependency and against a fake dependency. You might call that a verified fake, and there's some literature out there. There's the idea of contract tests, where you're testing not so much an integration, but you're testing specific behaviors that you know or expect out of a third party, and particularly if you are dealing with a third party that has some bugs, it might be interesting to write a test that says assert the bug still exists, and then if that ever changes, you'll know. And then finally, there's a very cool library called vcr.py, which is a kind of alternative to mocking and patching in the unit test.mock way, where it will let you run tests against a real API, and then it will record the responses, and the next time you run those tests, it's going to play back the same responses, and that can be a very neat solution to this whole problem. Although in my experience, it sometimes also gets very complicated. But you can read more about that on cosmicpython.com. I have a blog post on this topic called Writing Tests Against Third-Party APIs. So do go and check that out. So a little recap. What am I suggesting you should do? Stop using mocks. What should you do instead? You should build an adapter. You should explicitly build a wrapper, an adapter that represents your external dependency and that does so in a nice way, that has a nice API that looks good in your code. You should then try using, instead of mocking it out, you should try writing your own fake for it. So write your own fake class that pretends to be the real third party, and it's often a simple in-memory collection of some kind. So try doing that, and then try using dependency injection instead of using unit test.mock.patch to replace things, and you might find that this buys you more readable tests. Finally, consider using integration tests as your primary kind of tests for adapters. And then if you find yourself in a situation where you've got flaky CI builds and end-to-end tests, consider building a fake version of your third party for your tests. It's probably quite a lot less effort than you think, and it might get you a lot more payout than you would initially think. And then a little correct on why are we doing all this stuff? We're doing it because it's going to give us nicer tests, more maintainable tests that are easier to read and write, more reliable tests. It's going to exert design pressure, by which I mean that it's going to help you to think about how you're separating out your external dependencies and make sure that those are small and manageable and usable. And really there's this bit about forcing decoupling. So it's going to really force you to separate your business logic, the core of your application, the things that your customers really care about, from kind of low-level infrastructure details. Not because one is necessarily more important than the other, like they would both need to work, otherwise you wouldn't have written them, but because this allows them to change at different rates. I can change the API without changing the business logic. I can change the business logic without changing the API. So that decoupling, I think, will buy you a lot. So that's it. I hope you've enjoyed that. Thank you very much for bearing with me. Thank you for watching these talks during this strange PyCon 2020 coronavirus edition. Find out more at cosmicpython.com. Yes, I really appreciate your time. I hope you enjoy these things. If you do decide to try out stopping using mocks, please let me know how it goes on Twitter or wherever. Write a blog post about it. I'd love to hear from you. I don't know if I mentioned I've written a book. Thank you very much, and good night.